You know, it's almost impossible to wrap your head around just how big space really is. The distances are, well, they're just staggering. I mean, think about it. Even if we could travel at the speed of light, a trip to our closest stellar neighbor, Proxima Centauri, would still take more than 4 years. And a journey to the center of our own galaxy? Yeah, that's a cool 25,000 years. It's like we're living in this vast cosmic ocean, but we're stuck in a tiny little corner of it.
It really does seem like an engineering problem, doesn't it? Like, if our rockets are too slow, we just need to build a faster engine, put more power into it. But it turns out, the universe has a speed limit, and it's not a suggestion. It's a hard, unyielding rule that's woven into the very fabric of reality. So, what is this cosmic barrier, and why can't we just smash right through it? Okay, let's start digging.
All right, so the first clue in this whole mystery isn't some fancy piece of tech or a complex theory. It's just a number that shows up everywhere in physics. We're talking, of course, about the speed of light. And you have to understand, it's not just some cosmic speed to beat, it's a fundamental law that governs pretty much everything.
There it is, just shy of 300 million meters every single second. But this isn't just the speed of a photon in a vacuum. This number, what scientists call c, is basically a property of the universe itself. It pops up in the math that describes everything, from the energy locked inside an atom to the wild physics of a black hole.
See, this number does way more than just tell you how fast light moves. It actually defines the relationship between space and time. It sets the absolute upper limit on how quickly an effect can follow a cause. It's the key to the connection between matter and energy. It is, for all intents and purposes, the ultimate traffic cop of the universe.
And this quote just nails it. A speed limit sign on the highway? That's a rule somebody made up. You can break it. But the speed of light is completely different. It's a property of space-time. Trying to go faster isn't like speeding, it's like trying to draw a four-sided triangle. It's not that you're not trying hard enough, it's that it violates the basic geometry of reality.
So, who's the genius who figured all this out? Well, the main person of interest in our little investigation is, no surprise, Albert Einstein. His theory of special relativity didn't just explain the speed limit, it showed us, with some pretty terrifying math, exactly why nothing with mass can ever reach it.
Okay, so picture this. You're in your spaceship and you start getting close, really close, to the speed of light. Things get weird, fast. For anyone watching you from the outside, time for you would seem to slow to a crawl. But the real showstopper, the thing that builds a wall you just can't get through, is what happens to your mass.
And this all comes down to a wild idea called relativistic mass. The faster you go, the more energy you have. And because of Einstein's famous equation E equals mc squared, we know that energy and mass are basically two sides of the same coin. So as your energy of motion goes up, your effective mass goes up right along with it. The faster you move, the heavier you get. And here's where all falls apart for our interstellar dreams. It's not a straight line. As you get closer and closer, 90% of light speed, 99.9999%, your mass just skyrockets. It follows a curve that shoots straight up towards infinity as you approach that final untouchable speed.
So what does this actually mean for our poor spaceship? Well, to make something go faster, you need to pump in energy. But if the thing you're pushing keeps getting heavier and heavier, you need more and more energy for every little bit of extra speed. So to push an object that now has infinite mass, well, you'd need an infinite amount of energy. Literally, all the energy in the entire universe wouldn't be enough.
And right there, that's the final word from relativity. It's not an engineering problem we can solve with a better engine. It's a fundamental no. The universe is basically built an infinite energy wall that slams the door to light speed shut for anything with mass. Case closed.
Okay, so if we can't just floor it and break the speed limit, what if we could find a loophole? You know, cheat a little. What if, instead of trying to move through space, we can manipulate space itself? This is where our investigation goes from hard physics into some seriously wild theoretical territory.
And that brings us to maybe the most famous, most sci-fi idea of them all, the Alcubierre warp drive. It's a mind-bending concept for getting from A to B faster than light. But here's the trick. The ship itself never actually breaks the cosmic speed limit. So, how on earth does that work?
I mean, the idea is just genius, right? You aren't moving through space, you're moving space itself. Your ship just chills out in a little bubble of normal space-time. But in front of that bubble, you scrunch up space-time, and behind it, you stretch it way out. This creates a wave that pushes your bubble, and you, along for the ride, potentially getting you to your destination faster than a beam of light could. But, and this is a huge but, to do this, you need something with a negative energy density. This so-called exotic matter has properties that pretty much defy all known physics. We've never found any, let alone figured out how to make it.
So the warp drive is a long shot, but it's not the only one. Now we're getting into the really weird stuff, the kind of ideas that live on the absolute fringes of what we even think is possible.
First up, you've got wormholes. These theoretical shortcuts through space-time, like cosmic tunnels connecting two very distant places. Then there's quantum tunneling, a bizarre, real phenomena where tiny particles can just pop through barriers they shouldn't be able to cross. And then you have tachyons. These are purely hypothetical particles that, if they exist, are born traveling faster than light and can never slow down.
But, and you knew there was a catch, right? While all of this is fascinating to think about, it is pure theory. We have absolutely zero proof that stable wormholes can exist or that tachyons are real. To make any of these a reality would require a revolution in physics, a total rewrite of our understanding of the universe. And this is such an important point. Science isn't closing the door forever and saying never. It's just saying, hey, based on everything we currently know and can prove, this is the deal. Our knowledge defines the boundaries, and those boundaries, well, they can always change.
Okay, so let's put it all together. After digging through all the clues, from Einstein's solid laws to the wildest sci-fi theories, what's the final verdict? Why can't we go faster than light? Let's lay out the case.
We are up against some serious walls. There's the energy barrier, you need infinite energy. The materials barrier, we need this exotic matter that we're pretty sure doesn't exist. The knowledge barrier, we don't even have the physics to describe this stuff properly. The technology barrier, we have no clue how to actually warp space-time. And maybe the biggest one of all, the causality barrier. A lot of these ideas could lead to time travel and paradoxes that would just completely break the logical flow of the universe.
And that really is the heart of it, isn't it? Breaking the light barrier isn't like breaking the sound barrier, which was just a tough engineering problem. This seems to be a fundamental rule of the universe's operating system. It's not a limit on our technology, it's the limit on reality itself.
Everything we understand about the cosmos, from the Big Bang to today, is built on these rules. Our whole worldview depends on C being the absolute limit. But here's the thing. What if we don't have the whole rule book? What if we've only read the introduction? It's entirely possible that some future breakthrough, maybe when we finally figure out quantum gravity and unite the worlds of the very big and the very small, will reveal something new about space-time. A new rule, a hidden clause, a loophole that we never even knew was there. So, will we ever travel between the stars faster than light? The honest answer is maybe. We just don't know. Based on everything we know right now, the barrier seems absolute. But the entire history of science is about breaking barriers that once seemed absolute. Maybe the real speed limit isn't out there in the cosmos. Maybe it's right here, in our own understanding. And to break that one, we first have to shatter the limits of what we think we know.